Hey, viewers, nobody tell this drill press vise that it's being used to make its own replacement, okay? Thanks. Hello Internet, my name is Quinn, and this is Blondihacks. I'm back on my float lock vise build today, and I'm going to make the jaws, the defining property of a vise, if you will. If you are new to this project, make sure to check out my playlists. I of course have a playlist for all of my major projects, so you can follow along. And in this one, you will be shocked to see the lengths that I will go to for a good chamfer. So let's go. For material for these jaws, the McMaster man brought me this nice piece of 4140, which is a very tough steel, and it can also be heat treated, so you can harden the jaws if you are so inclined. I've ordered this right at nominal size for the jaws, and I'm not going to be finishing every surface. That's going to save me a lot of machining time here, because not every surface needs to be finished on these jaws. I'm going to start by cutting it roughly to length here on the big horizontal bandsaw, because this is very tough stuff and it cuts and machines very nicely, but you can see the smoke coming off there. It makes a lot of heat. This is tough steel and cutting it is a lot of work for the tools. To the mill now to clean up the ends. I'm just going to set this up like so, tappy tap tap that in, and machine the sides flat and square. Luckily I've got just enough end mill here to where I can do this all in one pass. This 4140 makes really beautiful chips when side milling. Got a nice sharp end mill here as well, which does not hurt. Finish on that is really actually quite outstanding. Quick deburr, and now I'm going to establish the length for the other side. To do that, I'm going to use a scriber here. I mean, you could do this with the DRO, but you know, I try to show different ways of doing things. So I've set my odd leg dividers there to length from the calipers, and then I'll just scribe the final length that I want. This dimension is not critical, so just milling to a scribe line is perfectly adequate here. So tappy tap tap that in, and then I can just side mill all the way down to my line. I had quite a lot of side milling to do here. I was overly pessimistic with my saw cut, but that makes lots of big fluffy chips, which makes Swarfy the duck happy. So far so good. Now I'm going to set up a test piece here, and I'm going to try something for making the internal Acme threads for these jaws. I want to test it out on a piece of scrap here before I do the real thing. So this is the same material, same thickness, for realistic real-world conditions on this operation. This happy fellow is a 1/2-10 Acme Tap. Wait, hold on. Just gotta wait for the booing to stop. Yes, I know you all wanted me to grind a single point cutting tool and do an internal threading operation on the lathe for this thread. And that in fact was my plan until two extremely generous viewers offered to send me one of these very expensive taps. So I decided to give it a shot, and if for some reason it didn't work out, then I would single point cut the thread. Now, if you really want me to do the single point cutting, then go ahead and watch my recent video on internal threading, because that's exactly what I would have done entirely in that video, except that I would have ground a 29-degree tool instead of a 60-degree tool. There, are you happy? Yay! But let's talk about Acme Taps, because they're really interesting. Look how long it is. Here's the equivalent size 1/2-inch thread in a normal tap. This is a 1/2-13, so very close in geometry to that Acme Tap. But look how much smaller it is. The very long gradual taper on an Acme Tap really has more in common with a broach than a standard tap. So let's look at this broach here. Both of these are solving the same problem. You have a very high tool pressure operation. On the left, we've got a very wide flat thread geometry we're trying to cut, and on the right, we're trying to turn a round hole into a square one. Both very high tool pressure operations, so you have to do it very gradually in very small bites. Hence the very long taper on both of these tools. So when you look at an Acme Tap, think broach. But I had no idea what I was in for with one of these taps. They are quite a lot of work. So I've got it set up here on the drill press with my spring-loaded tap follower. You can see the size of this thing. It's so long that my drill press is the only machine I have where I can do this. I've got the pilot drill size, actually a little bit oversized. I went 6th out over on that just to make it a little easier on myself. And of course it started out fine because I'm on the very small end of the taper there, but pretty quickly it started to get tough, and I was backing out to break the chip very frequently, but I quickly had to switch to gloves because my hands were getting sore from pulling so hard on this thing. And it got to the point where I just couldn't pull it anymore. I wasn't strong enough to turn this. The tap wrench I'm using is really not big enough for a tap this difficult. So I had to get out the cheater pipes at this point. And look, I'm not proud of this, but I will say it worked extremely well. This is just a couple of lengths of galvanized electrical conduit. And I tried to make them as short as I could and still do this operation so as not to overstress my tap wrench there too much. And I'm backing it all the way out a lot to clear chips, and I'm using lots and lots of cutting fluid. I just drenched this thing in cutting fluid. But even with all that, this was quite a lot of work. But the gloves and the cheater pipes did get it done. The end result, though, actually looks really good. That tap did a nice job. That's a nice looking Acme thread in there. The question is, does it work? Because here's the lead screw that I made in the last video, and it looks nice, but is it actually on dimension? I'm not actually sure until this moment if it's going to work or not. As you know from that video, I had my share of rigidity and chatter problems, so I wasn't sure if this thing was going to thread nicely all the way down or if it might be thick in the middle or something like that. But I'm glad to say this worked extremely well. I ran it all the way down and it didn't have a single problem, so very pleased with that. And because the tap worked so well, I am going to use it on the final jaw. I'm sorry, I promised to single point cut some things in the future. Back to the mill now. I'm going to set the bars up using a repeatable setup here. I'm just aligning with the fixed jaw there as an end stop because I need 2 holes in each jaw in all the same places. So this will be repeatable and nice and quick. So I'll start by finding the edge and the center line here, and now I can translate over to the first hole here. The back of each jaw has a 1/2 inch hole for the smooth guide bar, and then the inner part of the jaw has a hole for the crank on one jaw, and then of course the threaded nut on the other jaw. I'm opting to minimize tool changes here, so after the center drilling, I swap in the other bar and center drill the next 2 holes, and then I can switch out to my first drill size and do those in this jaw. And I'm going to start with a pilot drill. All 4 holes can start with the same pilot drill. With careful drill size selection here, I can optimize my operations a bit here. So I can pilot drill all 4 holes. Once again, after doing the first one, I swap to the other jaw, save myself a tool change, and pilot drill the other 2 holes. For the next size up, I chose the pilot drill size for the Acme thread because I can drill 3 of the holes with this size, and again, save myself a bunch of tool changing. The guide holes are going to have to go 1 more drill size up yet, but because this is 4140 and it's pretty tough cutting for my little mill, it doesn't hurt to have an intermediate size there between the pilot and the final drill. Look at all the smoke. You can see how much heat this stuff makes when you cut it. That is some tough steel. It's good stuff. On the other jaw, I can use this same mid-range drill for the guide bar in the back, but you see I marked an X there on 1 hole so I don't accidentally drill that one out because that's the crank pilot bearing, and that needs to be smaller than the current drill that I have here. So I'll drill out that back hole, and then I switched to the final drill size for this hole here, which again acts as the bearing for the crank. I drilled that out nominal size, knowing that drills tend to cut a little oversized, so that should give me a thou or 2 of clearance around that shaft. So I'll do a little test fit here, and that fits really well, a little bit too well actually. That might be too snug, but we'll see. It doesn't go all the way down because there's a burr on the back of the hole, but we'll see. If that's too snug, I can run a reamer through that, or I can polish down the shaft there a little bit. I'll wait for final assembly on that. And the largest drill size now, this is 1 size below the reamer that's going to be used in these holes. The smooth ground guide bars are going to be running in here, so I want these to be a close fit. Then once again, out with the old, in with the new, and I drill out that hole as well. Now onto the reamer. So this is the final size here that I want for this, and I'm running the machine about half speed for what you would for a drill. And I think it's better if you can, for a through hole like this, to run the reamer through in one motion, not pulling it back out to clear chips like you would with a drill. You can't always get away with this if it's a blind hole or if the hole is a lot longer than the flutes on the reamer, because straight fluted reamers like this are not good at clearing their own chips. However, if you can get away with it, I think the reamers leave a nicer finish and you get a tighter tolerance on that dimension if you can do it in one pass like that. I'll do a little deburr so I can test fit with the guide bar and see how close that fit is. And boy, that's a beautiful fit. Again, that might be a little too close for something that's supposed to slide back and forth, but we'll see. Once again, I could run an oversized reamer through that if we need a little more clearance on that, but I'll wait for final assembly. Now over here on the pilot drill for the Acme thread, I'm going to put a very generous chamfer on there with my zero flute chamfering tool. The coarser the thread, the more of a chamfer you need on the hole, so I'm putting a very big chamfer on that. That helps prevent burrs on the hole after the threading, and it's going to help ensure that these jaws can close up tight all the way afterwards as well. And of course, remember that repeatability is not just for part to part, it's also for the same part on the other side. So this setup allows me to just flip that over, align it on my stop once again, and chamfer the other side of that hole. Quick and easy. Okay, moment of truth. I gotta tap this hole now. I'm gonna do it once again on the drill press. I don't have the height on my mill. I could do it on my lathe, but it's difficult to get those cheater pipes in around the ways of my little lathe. So I think the drill press is the only practical way to do this. So to get it straight, I have to do this by eye because I don't really have a good way to do it otherwise on a round column machine like this. But, you know, by eye is good enough for a tapped hole like this. Lots and lots of cutting fluid, of course, and I got the gloves and I got the cheater bars, and here is the little dance that I'm doing. Now, I love a good tap dance, but this is an Acme tap dance, which, I don't know, it's not as popular. It didn't really catch on the way that normal tap dancing did. You know, maybe it's my execution. Tell me what you think in the comments below. Wait, no, I don't want to know what you think about my dancing. Well, unless you're going to say nice things, then yeah, go ahead. I hope the movement of the drill press communicates how hard I'm working here. You really have to fight for every thread with one of these taps. They are not for the faint of heart. It's definitely faster and easier than single point cutting the thread, but this is a lot more physically demanding, I think it's safe to say. But fight through it I did, and of course towards the end it does get easier like any tap. There's a spot right in the middle where it's the worst. It's easy at the beginning and easy at the end. Moment of truth, does it work? Boy, does it ever. Look at that. That actually runs better than the test part did. When I did the test part, my vise wasn't super well secured, so I think the tap cut a little oversized, but this one is a really nice close fit, and it runs very smoothly in there. And how about a little love for the Starrett 93C tap wrench? I was just extremely unpleasant to this thing, and you would never know it. It looks factory fresh, so that is a quality tool. Hashtag not sponsored. Back to my little test piece for a moment. The drawing calls for a V-groove in one of the jaws, and I haven't decided if I'm going to do that yet, but I thought I'd do a test cut with this little 2-flute chamfering end mill that I have. It can be used for cutting small V-grooves, and I also have some, let's say, ambitious chamfering plans for these parts, and I want to see if this cutter can do it. So I went down to the deepest V-groove that this tool will do. It's pretty small. And the cutting went okay. It's a pretty aggressive form cutting tool, and so I had to take light cuts, and the resulting V-groove is not very large. So I think I'm going to forego that on the jaws, and I'm going to do the chamfering a different way as well. Alright, time to finish up these jaws. It's layout time once again. I need some big angle cuts on these jaws. So I'm going to mark the end point of the angle, and then using my protractor, I'll scribe that line on there like so. That's a 20-degree angle on the end of each jaw. Makes them look nice. That's a lot of 4140 to remove, so of course I'm going to start by roughing this in on the bandsaw. So I'll cut to just proud of that line here and remove most of the material this way. As I always say, the bandsaw is the fastest machine tool. To finish machine those surfaces, boy oh boy do I have the perfect tool that I've been itching to use. Out with the vise and in with this beautiful little baby. This is a tilting fixture table that a viewer gave me at the Barzy Bash a couple of years ago, and I just love any excuse to use it. This thing is so beautifully made. I believe it's Japanese. The brand on it says TII. People always ask me for a link to it, but I don't have one, I'm sorry, because it was a gift. With that indicated in, it's a simple matter now to tilt it over to 20 degrees and lock it down, and now I can machine those sloped features on the jaws. On my to-do list is to make a fence for this table because that's a really nice thing on an angled table. I haven't done that yet. However, I have found the perfect combination of thin and thick parallels that is a perfect snug fit in the back T-slot. So that's my field expedient fence. What that's going to do is give me really good repeatability here so I can breeze through the matching features on both of these jaws. With that clamped down, I can get the face mill in here and just machine that bandsaw cut down nice and smooth. There is a dimension that I'm aiming for the thickness of the small end of the taper there, but it's not critical. That finish is very smooth, but the tool marks are more visible than I would like, but that's okay. I'll be hitting this on the ScotchBrite wheel later. Now all I have to do is swap in the other part, and that fence has made the setup repeatable, so I just mill down to the same value on the quill DRO, and the two slopes will be identical. Now time for that ambitious chamfering that I alluded to earlier. I'm going to go ahead and crank this all the way over to 45 degrees, and I'm going to put a big beefy chamfer on almost all the edges of these jaws. These jaws are quite beefy themselves, so they really need a beefy chamfer to look right proportionally. I found that stacking up some parallels like so aligns the center holes on the jaw pieces with a T-slot in the table, which makes for an easy fixture that gives me access to one full edge of the jaw like this. Then I touched off with the cutter, and I'm just milling down a little bit at a time until the chamfer size looks about right. I tilted the whole world to 45 degrees here so you can see it right side up. That looks about right aesthetically. And then once again, this setup is all repeatable because of the parallels and the fence there. So I can just flip this end for end, mill down to the same value on the quill DRO, and the chamfer on the other side will be identical. No touching off or measuring required. Then for the ends, I can stand them up like this and do the same thing. There's a lot of stick out on that part here, but it's okay. These are pretty light cuts, so this worked out just fine. I'm not chamfering any edges on the business face of these jaws because you often need to clamp things right at the edges, and chamfers there would be annoying. What about chamfering those sloped surfaces? That would be a compound angle. Well, time to get crazy. Got my little toolmaker's vise here, and I'm indicating that in on the table. This toolmaker's vise is way too nice for me. This was a gift from a viewer. Hey viewers, Editor Quinn here. Now, sometimes Camera Quinn is a little bit of an idiot and Editor Quinn has to deal with it, and this is one of those situations. I'm doing a compound angle cut here, but a compound angle can be set up with any two angles. As long as you have 2 degrees of freedom, you can orient the part to get the compound angle you need. And I always forget that this angle table has a rotating base on it. So all I had to do here was rotate the base, turn the part 90 degrees, then do the angle with the table, and I could have achieved what I'm about to do clumsily with angle blocks here. And honestly, it wasn't until I was editing this video that I saw the markings on the base on the table and remembered that it rotates. So sometimes you learn from your own videos. I'm going to bring in my angle blocks, and well, you know how this always goes. Won't even let me open the box this time. And yep, every time, Imperial Fist Shake. This box is my nemesis, and every time I show it, people ask, why don't you just put some more foam in there so that that doesn't happen? And the answer is obvious, because then it wouldn't be funny. Nevertheless, I grabbed the 20-degree angle block, and I'll set that up in the vise here, and that's going to bring that sloped surface into the plane of the mill table, thus making it no longer a compound angle. And over we go once again to 45 degrees, and now I've got that edge parallel to the plane of the table. That's all well and good, except that all this extra angling and such has pushed the setup backwards to where I can't reach it with the cutter. I don't have enough Y travel on my table. So I could redo this entire setup further forward on the mill table, or I could just put in a larger cutter. And now I can just reach it. But I'm not out of the woods yet. Look what happens when the cutter touches this edge of the part. Did you see it? Did you see what happened? Yeah, the part moved, so it's not secure enough. So I tightened that jaw down as much as I could, but still moved again. So this setup is not secure enough. To compensate for this, what I decided to do is take the angle block and clamp it into place. And this way the part can't shift downward in the vise, Normally with this style of angle block, you just rely on the grip of the vise jaws to hold the part in place because the angle block will slip out. However, this is a small vise and a big part and pretty high cutting forces, and it just wasn't sufficient. So clamping the angle block in there gave it the support it needed. Now this worked, but now I realize why this was so difficult to clamp. That cutter is vibrating a lot. I think it's actually dull. So I swapped that out for a sharp cutter, and now this is cutting beautifully. So maybe with a sharp cutter, the previous setup would have been okay. There's also a different style of angle block where each block has a little 90-degree hook at the bottom so that it'll stay in place in the vise, and that would have solved this problem as well. And if I was to do this over again, I might have invested in that style of angle block instead of the ones that I bought, but they still wouldn't stay in the box. I love an exotic setup, and, well, it doesn't get much better than that in my shop. This is very pleasing. It just goes to show, never underestimate how far I will go for the perfect chamfer, people. What's that? This was a lot of effort for some chamfers, you say? Well, shut your pie hole and open your peepers. Look at that compound corner. That is just beautiful. Little details like that are the best part of some projects, and I think you can't argue with that result. For the next feature, I want the jaws correctly referenced to each other, so I'm using a gauge pin in the guide bar holes there because that's really the reference that's going to control the position of these jaws relative to each other in the real world. So with those locked together like that, now I can set it up in the vise, and I'm going to mill a step in each jaw all the way down the center here. I'll center up using the vise jaws there, and then I've got an end mill set up for slot cutting. This is a really nice feature of this design. It gives you a little step on each jaw for holding small and thin parts close to the top of the jaw. Holding thin parts in most drill press vices is really difficult and annoying, so this is a great feature. And then if you want access to the top edge of the jaws, then you can flip the whole float lock vise over and use the other side of the jaws. It's a really nice design. This was done in a lot of light passes because slot cutting is already a difficult operation, and in 4140, it's just that much tougher. One last little detail, I'm going to set them up like this. Again, locked together with that gauge pin and just machine both pieces together. There's nothing more annoying than tips of vise jaws that aren't perfectly aligned, because then if you try to clamp something small right at the end, you can't. The part tilts because the jaws don't align right on those top edges. Super annoying. So the easy fix for that is just to machine them both together like this and make sure that they're perfectly aligned. And I got a nice finish on that, so that worked out great. To finish the surfaces now, over to the ScotchBrite wheel. A couple of those surfaces were unmachined, as I said, at the top of this video. So I'll just clean those all up on the ScotchBrite. And the ScotchBrite also takes out most of those tool marks that were annoying me a little bit on the sloped surfaces there. For finishing, I'm going to cold blue these. I think that'll look nice. Success with cold bluing is down entirely to how clean the parts are. So a very thorough and careful cleaning with acetone is the first step. And then into the cold bluing solution they go. This happens to be Jack's Steel Blackener. Works well when you can immerse the parts like this. So after a quick dunking, then they go into the water to stop the reaction, and then immediately dry them thoroughly. Once the part is dry, it's really important to oil it thoroughly and immediately, otherwise the parts will rust, because cold bluing is actually a form of rust. So the oil seals it and is the real rust protection. The cold bluing isn't really much rust protection, it's mostly for appearance. It will absorb a lot of that oil, and then you can wipe off the excess there. And that is the finished part. That will stay nice and rust-free for many years. There's my final jaws. I did forego the V-groove. Honestly, I never cross-drill round stock in the drill press anyway, so I think the V-groove would just be annoying. There's a mock-up with all the parts so far. And let's do a quick demo of the opening and closing action. It's a little hard to do with fingertips here. It'll be much easier with the crank on there, but it does in fact open and close, so it's really starting to look like a float lock vise now. Exciting progress so far. Thank you very much for watching. Thanks to all my patrons who make all of this possible, and of course those who donate tooling. You've seen many of those donated tools used in this video, and that means a lot to me. So thank you all very much, and I will see you next time.